Okay, now that you know how to do the tangent of a right triangle, section 7, 6 goes into sine and cosine. These are two more trig functions that we use to find different parts of a right triangle. Just like tangent has an acronym, we use the TOA, T-O-A. So too do sine and cosine. Now, the sine of an angle, again, let's use our angle A as an example. The sine of an angle uses the opposite over the hypotenuse. Sine equals opposite over hypotenuse. Now the way that we can abbreviate that is S equals O over H, so we get the SOH, or so. Cosine, still cosine of an angle. We'll use angle A as our example. The cosine of angle A is the adjacent over the hypotenuse. You remember tangent dealt with opposite and adjacent. Sine and cosine bring in the opposite and the adjacent, but they incorporate the hypotenuse. Tangent doesn't use the hypotenuse, sine and cosine do. The cosine of an angle equals the adjacent leg divided by the hypotenuse, and so we can use C equals AH, and we actually get Ka. Now, if you combine all these three, and you put sine first, and then cosine, and then tangent, you get Sohcahtoa. Now, Sohcahtoa is a way to just remember the three basic trig functions, where you have sine equals opposite over hypotenuse, you have cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. And this just helps you set up your problems to solve for different angles. At the end of this chapter, you're going to have to solve right triangles, meaning you're going to be given an angle and a side, and you're told to solve for all the missing sides, solve for all the missing angles, and Sohcahtoa is a really good way to help you find that. But just like tangent, we used a ratio of an opposite side divided by an adjacent side. It's the same thing with sine and cosine. And now that you know how to solve for tangent, we're just going to start practicing with sine and cosine. So go to the next page of your notes, and here in example 1, we're told to find not only the sine of x, but the sine of y, and then also the cosine of x and the cosine of y. And we're told to write your answers as both fractions and as a decimal rounded to 4 places. So at the top of my paper, the first thing I'm going to do is write the SOH. And over here, I'm going to write the CAH. So, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And I'm going to use these to set up my equations. So, the first thing I'm going to do is do the sine of x, of angle x, equals, and remember, opposite over hypotenuse. Now, if you take the angle x and you go to the direct opposite side, opposite, not the adjacent, not the hypotenuse, but the opposite, you get 8. And then if you do the hypotenuse, now the hypotenuse is across from the 90-degree angle. Here's my 90-degree angle, and if I go across from that, that's my hypotenuse. Notice it's 17. Well, the sine of angle x equals 8 divided by 17, which means the sine of angle x is 0.4706. Now, 8 over 17 is reduced. The reason I know it's reduced is because 17 is a prime number. If either one of these two are prime numbers, then they can't be reduced. So I know that that's as far as I can go. That is a reduced fraction and a decimal to 4 decimal places. Now let's do the sine of angle y. The sine of angle y. Now it's still opposite over hypotenuse, except that now I'm dealing with a different angle. I'm going to erase this so we can see it again. I'm going to circle angle y right here. Still opposite over hypotenuse. If I go to the opposite side of angle y, the opposite side, I get 15. So 15 over the hypotenuse. Remember, the hypotenuse is across from the 90-degree angle. Here's the 90-degree angle, and if I go across from it, I get 17. So 15 over 17. Now, 15 is not prime, but 17 is prime, so again, I know this cannot be reduced, but I do need to punch it into my calculator to find out what its decimal equivalent is. So I find out that 15 divided by 17 on my calculator is 0.8824, and that's rounded. Now that's sine. Now what I want to do is I want to go through the cosine of the same two angles. I'm going to do the cosine of x and the cosine of y. Now I'm going to erase my drawing so you can see all the angles again. Remember this, cosine is the adjacent over the hypotenuse, not the opposite, but the adjacent. And we dealt with the adjacent when we used tangent, so hopefully you remember the difference between adjacent and hypotenuse. Remember, adjacent means next to. Well, we're finding the cosine of angle x. Here's angle x. And the cosine uses the adjacent over the hypotenuse. Well, if we use the opposite side as 8, and we already know that across from the 90 degree is the hypotenuse, that covers 2 of my sides. That means that the last possible side that can be the adjacent side is 15. You can use the process of elimination if you want to figure out where's your adjacent side. Cross off the opposite side, cross off the hypotenuse, and the side that's left is the adjacent. But hopefully you can figure out that it's the non-hypotenuse side that's next to the angle. And I hope that makes sense. Again, as you practice this more and more, especially on tonight's homework, you'll figure it out. But our fraction is the adjacent, which is 15, divided by the hypotenuse, which we've already identified as 17. You'll notice that this fraction, 15 over 17, has already been used, which means that its decimal should be the exact same. The decimal of 15 over 17 is 0.8824, and that's rounded. You can plug 15 divided by 17 on your calculator and double check it, but we already know what the fraction is. Now, notice the difference, or notice the relationship between the sine of an angle and the cosine of an angle. Okay? Let's look at the cosine of angle y. Let me erase all this so you can see the drawing a little bit better. And now we are dealing with angle y, and we're looking for the cosine of angle y. Remember, cosine is the adjacent over the hypotenuse. What I'm going to do first is identify the opposite of angle y, because we don't need that. I'm also going to identify the hypotenuse, because we're going to need that in a second. But that is going to help me better identify the adjacent side. Adjacent is right here. It's not the opposite, it's not the hypotenuse, it's the one right next to my angle. In this case, it's 8. Well, we've already identified our hypotenuse because cosine is adjacent divided by hypotenuse. Here's my adjacent. Now I want to divide by my hypotenuse. I've already identified my hypotenuse as 17. Again, notice this fraction. This fraction, 8 over 17, has already been used with my other angle, which means that I already know its decimal equivalent, 0.4706. Now notice this. Notice how the sine of an angle and the cosine of the other angle are the exact same. You can see that here with the sine of x and the cosine of y. You can see that with the sine of y and the cosine of x. The sine of an angle and the cosine of the other angle, the non-90 degree angle, are the exact same. And that's going to help you here in a couple sections, or next section, when we use these fractions and decimals to actually figure out, okay, how much is angle x? What's the measure of angle x? What's the measure of angle y? And you can either use the sine or the cosine function. You'll notice, though, that you have the exact same answer for 2 different problems. You'll notice that again on your homework tonight. But what I would like you to do now is pause the video, take a few minutes, and I would actually like you to solve for the sine of x, the sine of y, the cosine of x, and the cosine of y for this problem right here. Go ahead and pause the video and try it now. Okay, hopefully you paused the video and took enough time to solve for the sine of x, the sine of y, the cosine of x, and the cosine of y. Now we're going to actually solve it together to see if you were able to solve it correctly. Now if you haven't done it yet, go ahead and try it on your own, and then you can just replay the video to see how you did. But let's start with the sine of x. Now here's angle x, and remember sine is opposite over hypotenuse. So what I want to do is I want to identify the opposite side and the hypotenuse side and represent that as a fraction. The opposite of angle x is 15. The hypotenuse, remember, is across from the 90-degree angle. Here's the 90-degree angle. So that means that is the hypotenuse. So you should have had a fraction of 15 over 25 for the sine of angle x. The question is that a reduced fraction? Or can you reduce it? The answer is yes, you can reduce it even further. 15 divided by 25 can be reduced to 3 over 5. The number 5 goes into both 15 and 25, so that 15 divided by 5 is 3, 25 divided by 5 is 5. You're reduced to 3 over 5. Then as a decimal, 3 over 5 is the decimal 0.6. So for the sine of x, you should have had 3 over 5 and 0.6. Then let's go to angle y. You'll see my answers here in a second. They're written down here, but they're written in invisible ink. Do you have invisible ink? Well, I do. Then let's go to angle y. Angle y is right here. Now we're still doing sine, which is opposite over hypotenuse. The opposite side of angle y is 20. The hypotenuse we've already identified as 25, which means that we get the fraction of 20 over 25. But again, this fraction can be reduced. And the number 5 goes into both again. So you should be able to reduce 20 over 25 if you divide both top and bottom by 5. You get 4 over 5. The fraction 4 over 5 as a decimal is 0.8. So for the sine of angle y, you should have had 4 over 5 and 0.8. Then we went to cosine of x and cosine of y. Now cosine is different than a sine because it deals with the adjacent side, not the opposite side. Let's start with angle x. The adjacent side of angle x, but not the hypotenuse side, is 20. Then divide that by the hypotenuse, which is 25. So the cosine of x equals 20 over 25. You'll notice that's very similar to the sine of angle y, which can be reduced to 4 over 5. As a decimal, that answer is 0.8. Then we go to angle y. Still cosine, so we're dealing with adjacent over hypotenuse. Now the adjacent is 15, the hypotenuse is 25. 15 over 25, just like the sine of x, can be reduced to 3 over 5. And as a decimal is 0.6. Now here are my answers, and you can see whether or not you got them correct. Again, the sine of x, we started as 15 over 25. We reduced that to 3 over 5, and as a decimal as 0.6. You'll notice that's the exact same answer as the cosine of y. The sine of angle y, we started with 20 over 25. We reduced that to 4 over 5. And as a decimal, that ends up being 0.8, which is the exact same answer as the cosine of x. Now, this is all you're doing for tonight's homework. Similar to last night, or the last time we met, you dealt with tangent, where all you had to do was find the fraction and the decimal for the tangent of an angle. Remember this, the Pythagorean theorem deals with the sides of a right triangle. Trig ratios deal with the angles. And we're going to see how to find those angles coming up in the next section. But let's go ahead and make sure that you understand how to do the sine and cosine of angles. And let's practice by looking at your homework now.